Hi everyone, I'm going to go ahead and go over the Desmo activity as I promised that we went over today in class. So on the first slide, please let me know how you're doing. I do like to read them to see how you are. Let's go ahead and see the first slide where it shows you two quadratic functions. One is in standard form, which is what you see here. So this is the standard form right here. And then the bottom one is the vertex form. So we have looked at both forms. Now there's an advantage for standard form, and that is we can see the y-intercept, which is our c value always. And in vertex form, the advantage is that we know that our h and k is our vertex. Slide number 3 introduces the third type of function we should be looking at, called intercept form. So this quadratic function is an intercept form, which means that we can see the x-intercepts, and it is written in the form of f of x is equal to a times x minus p times x minus q, where x equals p is one of your intercepts, and x equals q is another one of your intercepts. Now we just use the letters p and q, but we could have used any other letters in the alphabet, of course, except for x and y, because we already have those set as our input and output values. Slide number 4 is asking you to calculate the x-intercepts using the zero product property. So let's go ahead and do that. If you remember the zero product property, that states right here, the zero product property states that if we have two factors or even more than two factors, if a times b equals 0, then the only way this is true if either a equals 0 or b equals 0. So let's go ahead and use that property to find our x-intercepts. So we know that an x-intercept is when y is equal to 0. So we're going to go ahead and write 0 equals 2. In this case, our function is x minus 4 times x plus 2. So using the zero product property, the only way this is true is if one of our binomials right here, either x minus 4 equals 0 or x plus 2 equals 0. So we can actually write it as x minus 4 equals 0, x minus 4 equals 0, and x plus 2 equals 0. Now we're going to go ahead and solve for both of those. And you could probably do this mentally in your head. Solving for each one, I would add 4 on this side. So adding 4 on both sides, we get that x equals 4. So that's one of our intercepts. And solving for the equation on the right, if we subtract 2 on both sides, we get that x equals negative 2. So our two x-intercepts are x equals 4 and x equals negative 2. So let me see if it will allow me to type it in here. All right, so what you want to write here, it says answer in the text below. So you can say the x-intercepts are x equals to 4 and x equals to negative 2. Of course, you can also write it as an ordered pair, which means when x is 4, y is 0, and when x is negative 2, y is 0. So you could either write it as x equals 4 and x equals negative 2. Keep in mind that that means our ordered pairs 4, 0 and negative 2, 0. All right, so in this case, it says go ahead and place your x-intercepts on the graph, and then what do you think the axis symmetry is? All right, so let's go ahead and place those intercepts on the graph. We said we had one at x equals 4. So that would give us an intercept right here at 4. And then we have another intercept at -2. So that would give us an intercept right here. Now we know from a parabola that it is symmetrical, and the line of symmetry will split our graph in half. So where can I draw a line here where I would be equal distance from the two intercepts? So if you count it, you could see that I have 1, 2, 3, 4, 5, 6, and we want to go halfway. So 1, 2, 3 to the left or 3 to the right from any point. So it looks like our axis of symmetry is at x equals 1. Okay? So if you thought x equals 1 as your axis of symmetry, then you are right, because that is exactly halfway between our two intercepts. So let's go ahead and write that in the box below. It says sketch the axis of symmetry and write it in the text box. All right, so the AOS is x equals 1. All right, moving along to slide 6. Now it's asking you to place on the graph to sketch the axis of symmetry, the intercepts, and also now to find the vertex. Okay, so I'm going to go ahead and place those 2 points here. We have x equals 4 is one intercept, -2 is another. We have our line of symmetry is at x equals 1, so that is right here. Now, what do we know about the line of symmetry? We know that that is the first value of the vertex. We know that the vertex will always be on the line of symmetry. So right here on the bottom where it says, if the line of symmetry is x equals 1, to find the y value, we could plug in x equals 1 into this equation right here. So we could plug it in into this equation and find what our y value is. Now, just to go back up here, I forgot to mention that we did say it was halfway, the axis of symmetry or the line of symmetry. Another way you can do it is instead of counting the points in between, you can just take the average of the two x-intercepts. In other words, just add the two x-intercepts together and divide by 2. So if I add the two intercepts, I would get 4 plus -2 is just 2 divided by 2 is 1. So that is another way of getting the axis of symmetry. All right, but right now we want to calculate the vertex. So we can actually plug in 1 into the equation. What would that give us? So let's go ahead and see. If I wrote y equals 2, and then I entered 1 for x, and I have -4, so this is my equation, times, and then enter 1 plus 2. Simplify that. What do we get is our y value, or that will be our y value for the vertex. So 1 minus 4 is -3 times 1 plus 2, that is +3. And -3 times 3 is -9. So the vertex is 1, comma, -9. So after we have plugged in 1 into the equation, now there's 2 parentheses, so you need to plug in 1 for the first x and the second x, and then simplify. So scrolling down the graph, I'm going to go ahead and put a point at 1, comma, -9 right here. And what did it ask us to do? It says we know that x equals 1. We did that. Write the vertex in the text box below. Okay, so that is all we were asked to do here. I think the next slide will ask us to graph everything all together. So let's go ahead and take a look. So this is actually asking us to place the steps in the correct order for plugging in x equals 1 into the equation. All right, so the first thing we're going to do is we're going to look for the equation. Here's our equation in intercept form. I'm going to move it up here. Then what we're going to do is we're going to plug in x equals 1 into this equation. Now, the order in which you put these two doesn't really matter. Once we put in 1, so we could put this one above here if you like. So plug in x equals 1 to the equation. Here's the equation below. Plugging in 1 results in the following step. So we get 1 minus 4 times 1 plus 2. Then we're going to simplify that. When we simplify that, we should slide this slide here because 1 minus 4 is negative 3 and 1 plus 2 is positive 3. And therefore the vertex is, this should go below because after we multiply negative 3 times 3, we get negative 9. And then the vertex is 1 comma negative 9. All right, moving along to slide number 8, I believe it is asking us to sketch the graph now. Okay, so now that we have everything, let's put it all together. I have axis of symmetry at x equals 1, so I'm going to go ahead and draw that. I have the vertex, let me use this pen. I have the x-intercept at negative 2, so I have a point here. And I also have an x-intercept at positive 4, so I have a point here. Okay, so equal distance are the intercepts. And the vertex is 1 comma negative 9. So I'm going to go ahead and go down to 1 comma negative 9, which will be right here. And we can draw our graph with these 3 points. Now, if you recall, I also mentioned that a parabola, when the a value is 1, will always have the pattern of 1, 3, 5, 7, etc. So from the bottom point, I could go up 1, right 1, and up 1, left 1. And from this point, I could go up 3, right 1. And from the point on the left, I will go up 3, left 1. And this should give me up 5, right 1, which it does. And this point up here will be up 5, left 1. And so we can see that the y-intercept is negative 8. We could also check it by plugging in 0 into the equation. Let's do it mentally. If I put in 0 to x here, I would get 0 minus 4, so that would be negative 4. And then if I plug in 0 here, actually I could just do it directly here. If I put in zeros to our x's, then I end up with negative 4 times 2, which is indeed negative 8. So that makes sense for our y-intercept. All right, so now I'm just going to sketch the graph, make it a U-shaped graph as best as you can, round on the bottom, not V, and go through the points as best as you can. And I'm going to put arrows indicating that the graph goes on forever. All right, so I'm going to pause the video here and continue with the next slides in the next video.